Hello, my friend. You are welcome to my channel called GenAI Elite. In this video, I am going to talk about the basic understanding of deep neural network. And I know that you might have seen already a lot of videos around that. And you might be wondering what is the new about deep neural network. So if you're novice and you have no fair understanding about deep neural network, so let me tell you, I'm running a course. Basically, I'm running a series of video where I'm helping people to teach or understand generative AI. Okay, and in this segment, I'm talking about mainly neural network because it's very basic to understand. So in this video, I am trying my best to give some different dimension, different ideas, some real-time example to just explain the concept. What is the deep neural network? How it works? Okay. So let's get started. And if you really want to understand very basic level, watch this video till then. And I hope this is my promise. You will get a lot of value from this video. So let's get started and let's understand what is the hell the deep neural network in this video. So let us understand deep neural network. What is that? Deep neural network in this video. Okay, it is also called ANN, artificial neural network. Okay, so let us understand in very detail what is deep neural network and how it works. I hope you already have seen a lot of videos around that. Okay, so I know that my job is very tough to give some different idea, explain in a different way. So let us understand that. Okay, so if I talk about what is deep neural network, I hope you, if you have a background of ML, right, machine learning. So if I so I can you can see that ML this neural network, it's a subset of ML. Okay, let's suppose this is the ML. So this is the part, or you can say a small subset. Neural network NN is a part of ML. But you might be thinking, what is the difference between ML? How NN is different from ML? That I will cover in the last section of the video. I will give a very comprehensive differentiation or difference between ML and NL. But this is not the whole my idea. Okay, so here in this video, I want to explain in two ways. Okay, first I want to explain you this concept in a mathematical way. So first I will try my best to explain you or mathematical intuition. I want to establish a mathematical intuition of what is neural network. And second, I will try to establish a geometrical or graphical, you can say, geometrical intuitions, okay, of neural network, okay. And last, I will talk about little bit about how the ML and the neural network, how both are different, okay. So here, my whole idea, my attempt in this video is to establish a intuition in your brain, in your mind, that how neural network work. Okay, this is what I'm trying to achieve in this video. Just like a background, I want to put a background. This neural network, you might be wondering if already we have ML. Okay, we already have a ML skill set, or already we have already a ML solution. Then why we need neural network? Why we require neural network, right? So neural network is not very new. It has been since long time. Like researchers have been doing work in neural network from 16s, 1960s, 70. Okay, this has been doing a lot of research work people doing in this area. But this neural network has become popular very recently because of some reason. I'm not going to cover that all history. It is more like a history about that, how it happened. There's a lot of long history around that. I'm not going to cover that. Okay, but one person, I want to show one person. His name is Jeffrey Hinton. If you don't know his name, I would suggest you, if you really want to, if you really love neural network and if you really want to build good understanding about that, I will suggest you follow this person, Jeffrey Hinton. So only because of his attempt, because of his research work, whatever is happening today in generative AI, transformer, deep learning, it is only because of this person. So this person has given his more than 20 years of life on understanding and building neural network, building the concept, building the architecture. A lot of things they have research in this area. Okay, so I'm not going in that line. What is the history behind that? I'm not going to cover that. You might have seen a lot of video that. Okay, so here I want to talk about. Let us understand how it works. Okay, this is my goal here is not talk about history. My goal here is to explain you how it works, how NN neural networks works. This is what I want to build the concepts. Okay, so before I talk about mathematical and before I throw a lot of concepts that this is how it works, let me give a very practical real time example. Okay, because I really find that deep neural network or neural network is very close to our real life. Okay, so if you understand this real life, so it will help you to I'm just trying to build an analogy. Okay, so that it will help you to build some intuition around that. Okay, so let us understand one real tough problem. Let's suppose in your life, suppose you have made a decision that you want to achieve something. Let's suppose this is your target. Okay, you want to achieve something in your life. Suppose you want to start a business or you want to crack IIT. You want to do something, you have some target in your life, isn't it? Everybody has a lot of target, right? So in order to achieve this target, what you do, you take a lot of actions. You take action one, right? You take action one, this action may fail, then you take another action two, maybe this again fail, you take another action three. Okay, and finally after taking a lot of actions, and initially you do a lot of mistakes, we do a lot of mistakes initially, but every mistake we keep learning, we improving, right? And we take another action, another action, another action, and this way after taking a lot of action, finally we'll reach to our target. This is how our real life works, right? So, and this happens in everybody life, right? So just try to understand here how this whole process works. If you understand this whole process, it is very close to neural network. This is how, if you understand this whole mechanism how it works, you will understand neural network. That's what I'm trying to explain you. Okay, so let's suppose here at this point you decided that I want to take some action, I want to achieve my target, and for this target I want to take some action, which is action A. Okay, so in order to start this action, what you need some set of input, right? You need some set of input, or this input can be your thought, this input can be some suggestion from your parents, maybe from friend, maybe this is your maybe your own thought, maybe it can be your own initiative. Okay, you need some input, right? And out of this input, for each input, and this input will come from different direction, different ways. Okay, maybe all the input, when you start to take action, maybe all input has you will not give 100% attention to all inputs. Maybe some friends is saying that okay, you do this way. Maybe your close friend is saying if you do this way you will achieve this way. Okay, maybe your parents is saying something, your teacher is saying something, and you have your own intuition. So you will assign some weightage. What I'm trying to say that whatever input you coming, whatever thoughts or action or inputs you are receiving from different sources, okay, you will assign some weight. So suppose this is my x, my input, your thought, and for this x you're assigning some weight. So this weight is nothing but you are giving value. Okay, so let's suppose your teacher has given you some insight, or your teacher has given some you advice. Okay, so for the teacher advice you're giving more weight, and let's suppose this x is from coming from teacher. So teacher, for the teacher input you're giving more weight. Okay, let's suppose this x, this input or this advice is coming from your friend. Okay, so maybe you believe that maybe your friend is not giving right advice, right? You are, this is up to you, you assign some weight, you give some weightage for your some thought. So let's suppose you're giving suppose this is your teacher weight and this is your friend weight. Okay, and I'm assuming that the weight of friend is lesser than teacher weight. So this way what we get, right? So this way you get a lot of inputs, and for each input, based on your experience, based on your intuition, you assign some weight, right? And then You're receiving an input, you're receiving a weight, and then based on that, depending upon the you take some action, right? You take some based on this inputs, you take some action. Suppose you take some action, and this action depends upon the weight. Okay. Suppose you have given more weights to teacher. Okay, so whatever teacher is suggesting you, your result, okay, the contribution of this weight or the contribution of this advice into the result will be more, because you're given more weight to your teacher advice. Maybe you're not given more weight to your friend advice, or suppose vice versa. Suppose you're giving more weightage to your friend advice, you're giving less advice weightage to your teacher advice, right? So depending upon this weightage, depending upon this input, your result will be affected by this weight, right? This is what I'm trying to explain. So here what happens, so you got some, here suppose you want to perform this action A1. So from this action you got a lot of, you're receiving a lot of thoughts, a lot of advice, and for each advice you're assigning some weight. And depending upon the combination of weights, combination of advice, suppose you took some action, because unless until you don't took action, you will not get any result. Suppose you're getting insight, you're getting a lot of thought, but you're not taking any action, how you will get result? You will never reach to the target, right? So let's suppose at this point you took some action, you got some, suppose intermediate result O1. This is your not final result, this is your intermediate result. Okay, again this O1. Now suppose you got some this O1. Okay, now for this O1, you, this is, maybe this is not a final result, you got some result, you got some intermediate things. Now again based on this intermediate, maybe here you will get multiple maybe you will get multiple results. Okay, maybe you get multiple intermediate results. Okay, so based on this result, now you will take your next action, you will plan something new. Okay, I got some input, I got some result, then what next? Because in life may it is not happen just one shot. We get some intermediate result, then we take next action, next action. So let's just suppose here at this point, based on this output, again on these outcomes you will get some more weight. Let's suppose here initially for this output you understand that this output is not so much significant. Okay, this output is not much significant. Let's suppose O1 is more significant. So this is again your practical experience. Okay, again you will assign some weight, right? And based on this combination, based on this weight, you will take some action, you will get another intermediate result, and this way you will get some intermediate result. Okay, and let's suppose finally here you let's suppose you took three action, action 1, action 2, action 3, by follow this pattern, and you got some result. Let's suppose I got my O, this is my output. Okay, after three action. Okay, now after this subsequent attempt or subsequent action, once you got the result and you realize here, okay, at this point of time you realize that, oh, my output, what I have taken, whatever action I have taken, whatever weightage I have given to my advices, this output is not very close to my target. This happens, right? In our life we want to achieve something, but we reach to some different point. We, our intention is to reach to our target, but generally it happens that we never, maybe we are very close to target, or we deviate from our target, or whatever we wanted to achieve we could not achieve. It happens, right? So this output is not close to your target, you're not meeting your target. Then what you will do? Now here there are two options. Either you will stop here. Okay, well, okay, I tried something, I failed in something, it could not happen, I think this is not for me. You will stop, you will not do anything. If you do nothing, you will never reach your target, you just lost. It is over, right? But let's suppose you are smart, you are not going to stop. You want to, suppose you got this result, but you're not happy. Maybe this result is not the expected result you wanted to get. Then what you will do in your life? Then what you will do, you will do inspection, self realization, that okay, why I'm failing, or why I'm making this mistake, why I'm not getting the desired result, where I'm making the mistake. You will start from the beginning. Okay, maybe you will start from this step, previous step. Okay, in the previous step, what I did I mistake? You will just do, you will sit with your friend or teacher or wife, whatever, and you will do some discussion. Hey, you know that because of this reason, no, if I have taken this way, I could have get some different result. Okay, you will do inspection at every step, this step, this step, this step. Okay, and this way you will find a conclusion that, okay, I think this advice was not good, this advice was not in my favor. So you will, what I'm trying to say here, you will assign some new weightage. So whatever weightage you have given initially, and because of those weightage, you have not get the result. So maybe the problem is that I have taken the wrong advice, or maybe I'm moving the wrong direction. After realization, after discussion, you came to know that, okay, if really want to reach here, maybe whatever I have learned so far, because in this process you have learned a lot of things, you have experienced a lot of things. So maybe now next time you want to make some correction in your course of action, in your advice, right? So making a correction means what? You have to change the weightage, or you have to change the your approach, or you have to change the course of direction. I mean, technically, if I talk about mathematically, I mean, you are changing the weightage. Whatever advice you got, you again reassigning or changing the weightage. You're giving more weight to something else, and then again you're performing the action. And this way, maybe second time, you will reach the target. This is what happens in our real life, right? First time we take some decision, we take some action, and we failed. Okay, and once we fail, when we realize that why we failed, what was the problem. Okay, maybe I have taken the wrong advice, maybe I have taken the wrong action, maybe I could have done this way. So we go in our past, we realize, and we find that I should do this way. Let me change my approach. Let me change the weightage. Okay, this is what. And once you change the weightage, you take action. Maybe second time, maybe you're very close to your target. Maybe I'm not saying the second time you will achieve the success. Maybe the second time also you are very close to success. You could not get result. Again, you will go back. You will again find, okay, I think this time, no, I have to make this change. I have to make this very minute change in my advice or something in my action. Okay, so this way we keep on making mistake every time. And if you're smart enough, you understand that what is my mistake. You will not repeat the same mistake. You make some correction in your process, and finally, after making a lot of mistake, after doing a lot of correction in your action, ultimately there will be a time you will reach to the target what you wanted to achieve. This is how it happens in our real life. Okay, if you understand this process, my friend, this is what is the neural network touch. This is how the whole neural network work. Okay, so neural network, let me explain now mathematically. Okay, so before I explain the mathematically, uh, here right now what I'm trying to explain here is that this analogy I want to build. Okay, you take some action. Okay, you take some action, input, you getting some input, you take some action, and you make mistake. Let's make mistake. Let's okay, it's okay to make mistake. Okay, you took action, you got input, you make mistake. Again you go back and you correct your action, you correct your uh, whatever weightage. Suppose you given the weightage w right now, and with this weightage on input, you got mistake. You go back, you change your weightage. Now I'm giving some new weightage, and if I, with this weightage, with this advice, I'm taking any action, and maybe next time I will not make same mistake or zero mistake, and I will become successful, right? This is how the NN work. This is how this is a process or psychology or mechanism is behind the neural network mathematically. Now let me prove this mathematically. Okay, so before mathematically, there is another very famous, a lot of people give this example. Okay, that in our human also this our researcher, when this researcher were working on neural network, they took the inspiration. I'm giving some history around that. Okay, while building this complex process, okay, this neural network, they took some inspiration from human brains. Actually, the researcher researched a lot of brains, different like different brains, like insect, dog, cat, humans. and they find that human brains, finally they decide the human brains, okay, and they find that the human brains, how they work, they have a pattern, okay, they follow a pattern in the human brain, and let me show that pattern. So this is a pattern, okay, this is called neurons, okay, let me make it larger. Okay, so this is how our neuron works, okay, and a researcher, actually they research on multiple brains, and they find that while building the neural network, this brains has some pattern, okay. If you try to understand, our brains has multiple neurons, billions of neurons, okay. I'm just giving one, this is just one example of neurons, but our brains is made of billions of neurons, okay. And in every neurons, what happens, they have, it is called, this is a biological term, okay, so they have a dendrite, okay. So this dendrite, what they have, they receive the signals or they receive the input. Even in our life also, if you really want to do something, first of all you have to give the inputs. If you don't give input, you will never get result, right? So first you have to give the input, okay. Once you get the input, what next you have to do, you have to perform some action on that, okay. We are receiving input, we are receiving signal, and every input has some weightage, some biases, okay, and some value in that, and then you perform some action on that, okay, because unless until you don't perform action, nothing is going to happen. And when this action happens, you get some result. It is called intermediate result, okay. This nucleus is performing some action, you get result, and this result is passed to another neurons. So it happens, there are a lot of neurons are connected to each other, okay. One neurons is performing something, it producing some result, it is passing to next neuron, next neuron, and finally, okay, this whole output which are getting produced, they are getting transmitted inside the, it build a network. It's a kind of complex network they build, and this whole output are passed through multiple neurons, and finally there will be a output, okay. It is called action terminal, it is called terminal. Here you will get the output, multiple output, like this. So here I'm just going some saying the analogy of neural network, how it works, and how the researcher took a lot of inspiration from human brains also, while understanding, by building this complex architecture, okay. So this is how it works. So it has a lot of this, they have a lot of inputs, they perform some action here, and once they perform the action, they pass this information to multiple neurons. There are multiple neurons in the middle, and finally every neurons performs some set of action, and when the result comes, it is sent to our output, which is called terminal, and here we get the result, okay. This is how the our brains work. Let me come back. Now, what I explained, this process, this analogy, our real-time analogy, okay, the same thing our brains also work. Now, whatever I explained the analogy, that we receive inputs, we give some weights or value to our inputs, we perform some action, we perform multiple action, every action we get result, and finally we let's suppose we make some mistakes. Initially, we make a lot of mistakes, and once we make a mistakes, we correct it, we do some course correction, okay, and finally after doing a lot of correction, finally we get a result. This is how our life work, okay. Now let me prove it mathematically, whatever I have explained you, okay, like this analogy, the brains part, okay, it's okay. But in really, okay, so in the really, let me explain how the maths works. If you really want to understand neural networks, okay, really want to understand the maths behind neural networks, okay, so how it works. So before I give the mathematical formulation or mathematical intuitions, let me bring 2 points, okay. When I was studying neural networks, because I come from mathematics background, my background is mathematics. So when first time I was studying neural networks, I find that this is my own experience, okay. I find that neural networks is a math. This is my understanding. It's a complete math. It's a complete mathematical calculation. Okay, it's a complete mathematical calculation. And in NNN, I find that there are multiple branch of mathematics involved here, but according to me, uh, there are two important branch of maths like linear algebra. I will prove you. Okay, I will show that. I will show you right now. So there's a linear algebra and there's a multivariate. It is called multivariate calculus. Okay, so according to me, I find that in every neural network, if you understand the mathematical concepts, you will find that this neural network use extensively linear algebra. Okay, like in linear algebra, they use matrices, they use matrix, they use vector, okay, to store the data and perform matrix calculation. So they basically it's a linear algebra, okay, and uh, and then also let's suppose I told right, suppose you made some mistake, then how you will correct your mistake, how do the correction in the mistake, okay. So for that, for making the correction in the mistake, we use multivariate calculus, okay. Okay, if you know the calculus, there are multiple variables, like suppose if you're dealing with like function like y is equal to fx, okay, it's a two variable x and y, it's a two dimension, but in our data, in the real time, in the data is like multiple dimension, okay. So if I suppose I have x square, y square, z square, okay, something like t square, something is equal to 2. This is one equation, okay. So this has multiple dimension. It has a x variable, y variable, z variable, t variable. It has a 4 dimension, right? So in order to deal with multiple dimension, we have to use multivariate calculus. I'm not going into the detail of mathematics, but these are the branch of calculus which helps to deal with multiple variables. Okay, so linear algebra is heavily used, and multivariate calculus is heavily used in the neural network. Okay, I will explain you how these are used. Okay, so before that, I just wanted to give a heads up that these are the it's a complete, according to me, it's a complete mathematics. NN is complete mathematics. Okay, so now let me explain the mathematics. How now I'm going to explain you in the mathematics, because if anybody, okay, if anybody want to explain the neural network, it is not possible to explain without maths, because maths will be involved here. Unfortunately, if a person you don't like math, then it will be very difficult, obviously, to teach you that how it works. But it is a because math is pretty much required here. Okay, but yeah, let us understand. It's very not very complicated. I will try to make it very simple. Okay, so how it works, okay, so let me draw one picture, okay, then I will explain with the math. Okay, so as I shown you that in neurons we have multiple neurons, right? So even in the neural networks, suppose if I want to build a neural network, NNN, okay, I have to build neurons. It's a concept of neurons. Okay, so neurons is nothing but, you can assume like that, neurons is just like a according to me, it is like an action. You are performing some action, right? As I discussed in this example, we receive inputs, and for every inputs we do some calculation, we do some operation, or we do some function or do operation, which is called action. Okay, so neuron, you can assume that neuron is just a set of unit where we perform some action. It can be what kind of action we will do, we will see later, but let's assume that we perform some action. Okay, so in order to explain the neuron, we can draw the neuron graphically like this. Generally, we create a circle. Okay, in if you see the example of all networks, so we create circles. Okay, so here just to in order to make you very simple or explain you, let's suppose I'm taking 3 neurons. Okay, now you might be wondering why. The question will come in your brain that why we need only three neurons, why not 4, why not 5, why not 6? You can take any much. Okay, this is depend upon the problem statement. Okay, you can take any number of actions. That's totally depends upon your target. Okay, but in order to explain that, I'm just taking three neurons. Okay, and so suppose, so it has, okay, this is the architecture. I'm just explaining the architecture first. Okay, so first is this is the neurons. Okay, and there's a suppose you're taking multiple action, right? You take action one like this, like suppose here you take action one, action two, action three. So let's assume that these actions are neurons, this box are neurons, okay? And finally you have to reach your target, which is your output, okay? So here, this is my three set of action I want to perform, okay, from the input, and finally I will get output. This is my output, okay? So here, this is called architecture. So this portion, okay, this portion is called, it's a technical term they have given, it is called hidden layers. So you can see that we are creating layers, we are creating multiple neurons, okay? So it is called, this part is called hidden layers, hidden layer, okay? So from here, we are just, I'm explaining the real architecture, how the NLP works, okay? And then final one, where you want to see the target, because ultimately you want to get some target, you want to achieve something, some result, right? So this is called output, this is called output layer, okay? Now here, here, this hidden, this you can see that in this first layer we have three set of action, okay? Here we have a flexibility that I can create multiple layers. In the first layer, I have three neurons, okay? Maybe I can take another layer. That now next question might be coming, how I can decide then how many layers I need to take, okay? This is called, this is my first layer, this is also the hidden layer. This is the first layer, this is my first layer, this is my second layer, okay? I can take multiple layer, third layer, fourth layer, up to n. There's no any limit, okay, how much you can take. They don't talk about, there's no any fixed rule that you have to take uh, one one layer, two layer, three layer. There's no any such rule, okay? That totally depends upon your problem statement, right? So this is my first hidden layer, I'm giving a name, first hidden layer, and this is my output, okay? Though in the middle it can be multiple layers, okay? I'm not drawing that just to make it very simple. I'm giving very real, very simple example, okay? Now here, now I told that these are your set of action. This is my first action, this is my second action, this is my third action, and finally I will get output, just from my previous analogy, right? Now this action, if you really want to take action, what is the fundamental requirement, what you need? Just think about, you need input, right? Without input, without decision, suppose I want to become doctor, I want to start a business, I want to do something, you have to take some decision, right? You need some input, you need some thought, you need some discussion, only then you will take some action, right? So here, to start it, I need some input, some inputs. So it is called input layer, okay? This is called input layer. So it has, so fundamentally it has, these are the blocks in any, if you really want to build a network, these are the fundamental blocks. One, you have to think about input layer, second is the hidden layer, and there could be multiple hidden layer, not only I, for sake of simplicity I'm just showing one hidden layer. It is possible that it can have multiple hidden layers, okay? That totally depends upon the problem. And finally I have to take one output. This is very simple, I would say it's a simplet architecture of neural network, okay? Now let me explain, and this is how it works, okay? Let me explain, I'm giving some example. Let's suppose, let me relate with the ML. Suppose you might have seen ML problem, right? In the ML problem, what do, you take some tabular data, right? We have a tabular data, we take some data. If we have solved some ML problem, for example, let's suppose classification problem, okay? I'm taking example of classification problem in ML. What we will do, let's suppose, I'm giving very simple example. Let's suppose I have this data set. Let's suppose I have uh, uh, salary. Let's suppose I have salary, okay? One data set, one column, and I have city, okay? And then I have a purchase. This is one very simple data set. Okay, purchase. So here, if you know ML, I hope you know that. So let's suppose I could have multiple rows, multiple observation, right? So let's suppose salary is 2K, okay, and city, let's suppose it's I'm taking a lot of cities name, like it can be New Delhi, it can be Mumbai, it can be Calcutta, and for each city I have a numerical representation. I hope you understand that. Okay, let's suppose city is 1. Okay, so if salary is 2K, city is 1, let's suppose people can purchase. So suppose it's a sales data, and here I'm finding the classification whether people has purchased or not purchased. Let's suppose purchase, if it is purchase, I'm showing 1. Okay, let's suppose salary is 1K and city is 2. City 2 can be any other city like Mumbai, and suppose I'm saying purchase 0, it is not purchase. Okay, it's a very classical data, right? I hope so you know that. Okay, so my so here my it has it I have two feature here. One is the salary part, this is my first feature, F1, and city is my second feature, F2 feature, and this is my result, right? This is my outcome or result, that whether it purchase or not purchase. If 1 is there, 1 purchase. If there is 0, means it is not purchase. It's very simple ML, if you know the ML background, right? So here what I'm going to explain you, whatever I'm going to explain now going forward, I'm going to explain with respect to this data set, just to make it simple. Okay, so I have a salary, I have a city, right? Okay, all right. So now, okay, so with respect to that, let's suppose I have I'm making very simple. Let's suppose this is my uh, salary, and this is my city, and some outcome, purchase or not. Okay, suppose 2K, I'm city is 1, suppose purchase 1K, and city is 2, not purchase. Very simple data set. Okay, so with this respect, and my job, my outcome is what I want to do, classification, right? This is what I want to achieve. So let's suppose to solve this problem, I'm building a network, I'm building an architecture. Okay, one thing, my friend, ML and deep neural network. Okay, one of the basic difference, though I have not covered that, that in ML it is more like an algorithm. You might be using random forest or ensemble model. There are multiple model, right? So in ML it is more like a model. It's a algorithm. Okay, and the algorithm is more like a fixed algorithm. Once whatever algorithm you want to use it, you cannot change it. But NNN is not algorithm. This is one of the basic difference. Machine learning is an algorithm. Okay, it's an algorithm, but NNN is not algorithm. It is an architecture. Neural network is not algorithm. It is an architecture, and this architecture, there's no fixed thing. Okay, in algorithm it's a fix. You cannot change the algorithm. You have to abide by the algorithm. But architecture is like it gives you freedom to experiment or change it. There's no fixed thing in architecture. Okay, why I'm talking about that, that is why I can take multiple, that is why I can take multiple layers, I can take multiple neurons. There's no any fixed rule, because it's an architecture. You cannot there's no fixed rule. Okay, you can change it. This totally depends upon your problem statement. Okay, so here, let's suppose with this example, suppose I'm taking 3 neurons, neuron 1, neuron 2, neuron 3. Okay, one hidden layer and one output. This is what I decided my architecture. Okay, and here you have to give inputs, right? So let's suppose, and how to give inputs to this, we have to give this input, this network. So there are 3 ways to give inputs. Okay, let us understand that. Let's suppose I let me add one more row here, 2K. Let's suppose I have a 3K, I have city, suppose 5, and suppose it is purchase. Okay, so let's suppose I have 3 rows, I have 3 inputs. Okay, these 2 feature and 3 rows. Okay, so in neural network there are 3 ways to feed the input, because I told, right, if you really if you understand the previous analogy, you have to give some input. Okay, so I can give the input in 3 ways. The first input, like this, I can feed the first row at one time. I mean, salary and city. I can give 2K one. Okay, or either I can give one. I can give only first time one row, to second time one row, third time one row to process the network. Okay, or I can give some batch. Okay, first is one by one. There are three ways to give input. Okay, first is one by one. You feed the data one rows at one time. Second way is what? You can feed the data by batches. We will discuss in later. Okay, batches. Batches mean I don't want to give just a single row. I Let's suppose I want to give two rows in one batch. So in one batch, I will send two rows. This is what I decided. Okay. Third approach is to send data all in one go. I mean, I want to send all data, whatever data. Let's suppose I have 10,000, 1 crore, 2 crore data. So I will send all the data at one shot, at one go. Okay. So there are three ways to send the data or send the input: one by one, in the batch fashion, or all in one shot. Okay. That depends. Okay. So we will discuss that later. So let's suppose here, just for make it simple. So suppose I'm sending data in one by one. Okay. So at the input layer, okay, at this layer, I will send two data because I have two features. Okay, 2K and one. So salary is one feature and city is one feature. So here I will my in the input layer I will have two inputs. So this inputs, how many input will go inside the network, that depends upon the features. Okay, how many features you have, that depends upon the feature. So let's suppose here I'm taking one by one. So first we'll get 2K. Okay, the first input, and second the city one, like this. Okay, so here I have two inputs because I have two features, and I have taken three neurons, okay, in my first hidden layer, and I have taken one output. Okay, again I'm saying how to decide that how many neurons I need to take, how many layers I need to build. It is called hyperparameter. It again depends upon the situation. Okay, but right now we just want to understand how it works at the mathematical level. Okay, so this is my setup. I hope you understand the setup, right? Okay, so what is my data set? So in order to understand the setup, you understand what is my data, what is my features, and how many data we are inserting at one shot, either one row or batches or all the data. Okay, and then what are my hidden layer at one hidden layer, what are my neurons, what is my output. So let's suppose this is my setup. Okay, so with this setup, if you're able to understand this setup, then I will explain the mathematical approach, how it works. Okay, now as I told in the beginning, suppose this is my input. Suppose you want to take some action and you're receiving multiple inputs, right? So or you will receive a lot of inputs in your life, a lot of decision in your life, a lot of thought in your life, but you will assign some weight. I mean, you will give some value. That suppose if my teacher is giving this advice, I will give more weightage, and if my younger brother is giving my advice, I will take give lesser weightage, or my friend is giving, I will take maybe more than my younger brother weightage. Okay, so depending upon that's you decide. This totally you decide that how much weights you want to assign. So but we have to give some weight. Okay, so that is why for this 2K, for each input I have to give some weight. Okay, so let's suppose this is my first neuron. Okay, so this data, this 2K will go into this unit. It's the action unit. Okay, so this will go into this unit, and this will go into this unit. Okay, similarly, let me change the color. Similarly, this 2K will come into this unit, and this 2K will this will go into all units. Okay, yeah, in these all three, and this 2K, let me change this color. And what I'm trying to say that this data, this whole individual data will go into all the units. Okay, so 2K will go into first unit, second unit, and third unit. Okay, now let me change the color. Same 2K, Okay. Oh, 1 second. Let me start from scratch. Uh, okay. All right, guys. Yeah. So let me understand. Let's suppose I have three. This one. Okay. Now this 2k. Let's understand per data. This 2k. Okay. So this 2k will go into this unit. This 2k will go into this unit, and this 2k will come into this unit, right? The 2k is gone. Okay, all the 2k, all the first data has gone to all the units. Now think about 1k. Similarly, I'm changing the color. 1k, this data will go into this unit, this will go into this unit, this will go into this unit. Okay, this is how it works. Okay, now I told that, okay, I have the data, I am giving the data. Now important thing is the weight. Okay, I told that we have to assign some value or weightage, okay, to all my inputs, all my decisions. Okay, so how to give the weightage? Okay, so just think about, let me change the color. Okay, now think about from this neuron, the first neuron. Okay, this neuron, this neuron, think about this neuron. Okay, so for this neuron, data is coming from these two input. It is coming from 2k, it's coming from 1, right? For the, now think from the neuron perspective, just think from the action perspective. Okay, for this action to perform, I'm receiving two inputs, or two signal, or two thoughts, or two decision. Okay, because I have two decision. Okay, so now for this layer, for this input, for this action items, whatever inputs I'm receiving, one this one and one this one, I need to give some weight. I told, right, for every thought, for every inputs, you have to give some weightage. Okay, so suppose here for this one, okay, for let's suppose I can create here, let me create here only. Okay, so for this weight, okay, for this neuron, let's suppose for this line, okay, for this input for 2k, the input is coming from 2k to this, okay, this line. So this is my input. So for this input I need to give some weight, that I will decide. It happens at random in the neural network. You might be asking how much weight I need to assign for input, how much weightage I need to assign. I don't know. So how the network work? They give some random number. They initialize some random number. They assume that this is the right weight. Okay, even in life, even in your life, you don't know that whether this weightage is really good or not. You just give some, maybe based on your experience, based on your intuition, you assign some weight. Maybe this weight, I don't know. I'm not sure whether this weight I'm giving it is the right weight. Maybe I will not get result. Let's suppose I'm giving more weight to my teacher advice, and I'm giving less weight to my parent advice. It is true or not, I don't know. Initially I don't know, right? Suppose I'm assuming that my teacher input is more weightage, I'm giving more weightage, I can make mistake. And I will, if I make a mistake, I will come back, I will change my weightage. So that is why the weightage is just like a random. You start with something, and let us make mistake, and once we make a mistake, we will make a correction. This is how it happens. Okay, so here what I'm trying to say here, suppose I'm giving some weight, some number. So weight is nothing but some number, some number, okay, some integer or some numbers. It can be number, it can be fraction, anything. So here what I'm saying, that I'm, for just to represent that weightage, I'm giving some mathematical notation. So I'm saying that this is a weight, okay, and it is this weight is for first input, and it is going into first action item or first neuron. So I'm saying it, what I'm saying it, let me, yeah. So I'm this is my notation, by the way. This is a mathematical notation. Okay, just to represent some data, I'm saying that it is weight for first input, okay, and it is going to the first neuron. So W11 says that one is for source. Okay, this part is the source, and second part is the destination. Okay, so this weight is coming from where and it is going to where. What is the source, what is the destination? So this way you can understand. This is just a mathematical representation. Okay, so for this part, for this input which is coming from 2k to first neuron, I'm giving some weight. It can be any number fraction. Okay, now for this node, the next input is coming from 2, this one. Okay, so for this one I'm again giving some weight. Suppose I'm saying it is coming from second input going to first, so I'm noting here 2. I mean the second input, it is coming from second and going to where? The first neuron. First neuron. So according to, with respect to this neuron, these are my two weights, and it is completely random. It can be anything. I don't know, and I can make mistake. That's okay. Okay. Now think about this one. Now let me change my color. Okay. So this is so this weight part is done for first neuron. Now think about second neuron. Okay. Again, for second neuron, data is coming from here, right? And from here. So for this data, for this input, I can give some weight. So I can say that this is 1 coming from 1 and going to 2, second neuron. So I can say that weight coming from first input going to second neuron. Okay. Similarly, data is coming from 1 also. So for this portion, for this linkage, I can say that weight coming from 2 and going to second neuron. So it will be weight for 2 going to 2, second neuron. Okay. Similarly, for third neuron, let me change the color again. Now, think from the third one, from this perspective. From this perspective, again, the thought, the decision, the input is coming from 2k, this line, and this line, I'm giving some weightage. I can say that it is coming from first one and going to third neuron. So it is W1 and 3. And for this one, it is coming from 1 and coming to here. Okay, so I can say that this weight is for second input and it is going to third neuron. So it is just a notation, my friend. Okay, it is nothing complicated. It is just a notation. So it becomes my weights. Okay, so for this neuron, I will assign two weights because I have two inputs. For this neuron, I will assign two weights because again I have two inputs. For this neuron, I will assign two weight because I have two inputs. Okay, so this weight is for first neuron. Okay, this one is for second neuron, and this is for third neuron. Okay, so you can see that I can represent this as a matrix to just to store the data. Okay, I have multiple data. I have 6 data. To how to store the 6 data? Either I can take a list. If you know Python in the data structure, I can create 6 variables. Okay, uh, in each variable I can assign the each weights, or I can create a list and I can add this element. Or either best way is if you have multiple data, complex data, then you can create a matrix. So this data I am creating into matrix. Okay, so the first column, okay, the column wise. Okay, so the column wise, if you take the thing from the column wise, so the first column is the weight for first neuron. Okay, the second column is the neuron for second weight, and the third column correspond to third neuron. So this way I have given a random, these are the completely random weights. I don't know, okay, whether it's a right or wrong. I'm just giving some weight. Okay, so this way you can say that uh, now I hope you are able to compare with the first analogy which I given. Okay, so I have weights, and for each weights I'm giving some sorry, I have inputs, I have some thought, and for every thought, for every inputs I'm giving some weight, and I have a action. I'm taking 3 action. I'm taking 3 neurons. Okay, now this part is clear. Okay, now here I told that you will take some action here. Okay, and it will produce some result. Even here also you will take some action, it will produce some result. Let me make it, let me remove this. So it will become clean. Okay. Yeah. So now you taken three action. You have decided that I will take three actions item. I have three neurons. I have the weights. Everything is done. Now here it will take some action. Okay, it will receive all the inputs with all the weights. It will take some action and it will produce some result. Even for this action item, for this unit, again it's the same thing. It will receive the input and it will produce some output. It will also produce some output. Okay, and this output, how we give some name here, just a nomenclature. I'm saying that it is 1 1, it is 1 2, I'm giving 1 3. It's an intermediate result, it's not a final one. Okay, and then we have output, right? This is my output, final output. Okay, so this is my input layer. This part is my hidden layer. Okay, and every hidden layer are producing some intermediate result by some action. Internally what happens we will cover later, but just to understand that internally every unit it performs some action and it produces some result. Okay, and this result, whatever result they have produced, okay, again this result will go into output layer. Let's suppose it will come here. So this neuron, again it's a neuron. Okay, this neuron will receive the input from these intermediate results. So this will go here, this will go to same neuron, this will go here. Okay, and again for this neuron, according to this neuron, we have to give some weight, because every thought, because it's just a thought. Okay, for this neuron, if you understand, for this neuron it is just a thought, just an advice. It's coming from, suppose it's a teacher advice, it's a parent advice, it's a friend advice, it's just an advice, right? So how much weight you want to provide, that's again it's random. We have to give some weight. Okay, so let's suppose here I'm giving a weight. Suppose here, okay, it is coming from 1, right, and it is going to 1. I'm giving this weight. Here again it is coming from 2, it is going to 1. Okay, here again it is coming from 3, it is going to 1, because I have just one neuron. Okay, and because it's a second layer, okay, just because you can see that again here we have w the same, again we have w11 w11. Just to differentiate, I can say that it's a second layer. I can here in the subscript I can put some it is for second layer, it is for second layer, it is for second layer. Okay, this way we can differentiate. Okay, so for this neuron, what are the weights? W11 for second layer, W21 for second layer, W31 for second layer. So this is my weight. Okay, according to this neuron. Okay, and this whole weight assignment happens at random. There's no any fixed rule, though there are some rule behind that, there are some algorithm behind that, but it's very random. There's no fixed value. Okay, so this way we have a network ready. Okay, so this way we have the network, we have the weights. Okay, and let us understand, I discussed that. So this part is very important. Okay, a lot of people don't understand the weight part. So the weight part is just like how much weight or how much weightage you want to assign to each input. This is what we do. Okay, after that we do some calculation. Okay, so how to do calculation here? Let's suppose this, for this input, let me remove this. Okay, this is my first 2k. Okay, so here this 2k1, this is my input. I'm just giving some notation. I'm saying that this is x. Okay, let me get some space here. One second. Yeah, so this is my 2k, this is my 2k input, this is my 1. Okay, so for this input I'm giving just notation. I'm saying that this is x. Okay, how the input are given the notation, I call it xij. I will cover in the little. Okay, so let's suppose I'm giving, suppose here I'm saying this is x1 and x2, but just to make it simple. Okay, because I have just two input. In case of multiple input, how to deal with that, we have some notation. So let's suppose for this one, for this feature, I'm saying x1 and x2. Okay. Now, so now you have the setup ready. Okay, we have x1, x2, we have all the neurons, we have understand all the weights, and every neuron will produce some intermediate result. That result will again go to next layer, which is the output layer, and each layer will have its weight. Okay, now understand the mathematical calculation. Okay, so now here I have two inputs, x1, x2. Okay, and based on my setup, whatever neurons, I have the weights for the first layer and second layer, right? Now let us understand that according to the first for the first neuron. Okay, let us understand the calculation. If you understand this part, now let us understand the second part. I'm trying to explain the calculation part, how what happened, how it do the calculation internally. Okay, so let's suppose this is my first neuron. I'm just again drawing, I'm drawing the first this neuron. Okay, this part. Okay, so this part, this neuron is taking two input, x1, x2. It is coming, going into x1, from x1 to x2, right? And for this neuron, what is the weights? This one, this one is the weights. I have already understand that. Okay, so w1 for this neuron, the weights part are w11, w22, I think we have already explained that. Okay, so I'm considering from the unit by unit. Okay, so for this unit, these are the input, these are the weight. So how, what it does for every neurons, it will do a calculation, a mathematical calculation, and this is the calculation. Okay, it will multiply wx1 with w1. It will multiply x2 with second weight. So the calculation is this: x1 into w11 and do the summation, x2 into w21. Okay, so you can see that this w11, okay, it is a weight for first input. Okay, this part is the weight or the weightage of the first input, and 21, okay, it is the weight for second input. So we are multiplying the weight from their corresponding thought to just calculate the value. What is the value I got? Okay, let's suppose let's for example, let's suppose I have a teacher and I have a parents. Okay, the teacher weight I'm giving suppose 2, and for the parent I'm giving the weight 1. Okay, just suppose mathematical, I'm just representing some number, and the teacher input value is suppose 4, and the parent input is suppose 3. So what will be my value? 4 into 2, 4 into 2 for teacher, and parent 3 into 1. This is what I'm doing, right? It's very simple. It's simple mathematical. I'm just calculating the value based on my value. I'm finding the final value. Okay. So this is what happens. And additionally, one more thing: every neurons has its own bias. Okay, we add some bias. So bias, okay, bias, we add some bias term. Okay, why we add bias? Okay, again, you can add bias or you can omit it. Either you can take or not take it. If you don't take it, no problem. Okay, but it is always good advice to take bias, so that, okay, once this action, whatever action you just assume that, let's suppose you want to take some action. Okay, and if you're taking this action, why you taking this action? Because you have some sort of bias. You know that, okay, if I take this action, suppose you want to launch a business. Okay, and you're taking some action that, okay, if I start my website, then maybe it is good for my business. This is one action, right? So you have some bias. Maybe you have learned from experience, maybe your teacher have told you that you need a website, you have created bias, right? So every action will have some set of bias in our real life also. Whatever we action will take because of some bias. Suppose you are an engineer today. Why you're engineer? Because you had produced a bias in the beginning of your life that engineering is good. Suppose you're a doctor today. Why you're a doctor? Because you have some bias toward doctor, maybe by your parents, maybe by a society, then if I become doctor, it is good for me. This is real life, okay? So every action, every set of action will have some set of bias. It is very real life, right? So that's what we add for every action. We add some bias, okay? So this way we did a mathematical calculation, okay? So for the first neuron, this for the first neuron, we got the input, and for each input I have a corresponding weights, my weightage, and for each action I have a bias. So this is a mathematical calculation. We will equation like this, okay? And if you consider, if you take a very look at this equation, what is equation talks about? If you know the linear algebra, okay, this equation is nothing but a line, a straight line, okay? It's a linear equation. It is called linear equation, okay, because power is one, okay? So this is nothing but a line, okay? I will explain the geometrically, okay? So once you build this equation, you got this equation, okay, and after this equation, okay, what happened internally, okay? So this neuron got this input, okay, and after this we do some transformation. Whatever we got, whatever equation we found, whatever we got something, okay, we take some action and discuss, okay, and on this input we do some transformation. And once we do transformation, we get a result, because I told, right, we have to produce the result. Oh, so this is my input, right? Once we get the input, how to produce the result, okay? And this result, okay, will be different from this input. So this is your input, and from this input we want to produce O output. It will be different. So somehow we have to do a transformation. This input will get transformed into O by some set of action, okay? And what is the set of action, we will understand in detail. That is a part of neural network, okay? So this is how it happens, okay? Now you're able to understand, and this will happen for each neurons. For example, I just showed for first neuron. Similarly, it will happen for second neuron and third neuron, okay? And this way it will receive the input, it will form this equation, okay, and finally it will perform transformation, and it will produce a result, intermediate result, okay? This is what it does internally, okay? And it will happen to the next layer. Similarly, it will happen here also, okay? Now, so this is how it is. This is the first process, okay? It perform this whole equation. It's completed. This happens internally like a matrix operation. It totally is a matrix operation. We will discuss in later, okay? In this video, I just want to build the intuition. I don't want to go at very detail level, okay? I just want to build very high level detail, okay? So this is how it happens. We have inputs, we have neurons. Every input has some weights. We do calculation like this, okay? This we build these lines, and on that line we perform some transformation. What is the transformation, I will discuss later, and you will get some result. So every neuron has to produce some result, had to do some transformation, and this way this output will go to the next layer, next layer, next layer, like this way, and finally you will come to the output, you will get result, okay? And what happens, let's suppose you got the final result. This is your final prediction. We call it y predict, okay? Let's suppose let us understand for this input. Suppose I gave two, here I given 2k and 1, okay? And let's suppose my prediction saying that, my result is saying that no purchase, because this is my action, right? I want to predict whether purchase happen or not purchase happen, okay? So this neural network is trying to understand my data. So let's suppose with this network, okay, it is producing some output, and it is saying that not purchase, it is saying 0, but actually it was purchase, okay? Now think about why it is giving you 0, why it is saying that it is not purchased. It is only saying it is not purchased because of your weights, right? Because I told, right, suppose you wanted to achieve something, and in the beginning, when you got the inputs, when you got the thought, you got the advice, you given some weightage, and maybe in the beginning that weightage which you have assigned, it is not accurate. It is quite possible, right? We have just given some because this weight are just random. It is not, I don't know whether it's accurate or not. It's just random. So whatever weightage you have thought that it will work out, and maybe that is not accurate, that weight is not accurate, that is why you're not getting the right result, right? If you have given the right weightage, suppose you are God and you know the future, okay, this advice I have to give this weight, this advice I have to give this weight, I have to take this weight, I have to take this bias, and you take very right action. Suppose you know everything, you know the future, you are God, you are taking very every step, every right action, you will know it, you will always get right result, right? But it will not happen in the real life, right? Because our weight are very random, I don't know whether it's the right weight or wrong weight. So that is why it is highly chance you will not get the right result. How we find that? Because my right result is 1, but I'm getting 0, which is not matching. Okay, this is my not my right target, my right result. So what to do? So here, that is why what I will do, because I told, right, I have taken the wrong weights. My weights are wrong. My bias are wrong. My assumption, because these are just like a assumption. We have assumed something. Okay, this weight will work, but it is not working. Then I will go back. Okay, this is a process that I will go back, and whatever weight I had assigned, because this is just an assumption, I had assumed that this weight will work, but actually it is not working. So I will go back, okay, and I will update my weights. So it happens, okay. So first we assign the weight, we do calculation like this, we build this equation, we produce result, and then finally we get a result. If result is not matching with the expected, we go back and whatever weight we had taken, we update. This all weight will get updation. Okay, it is called, this is a process, okay, it is called back propagation. I will talk about that. So this is what happens. Okay, once I correct the weight, let's suppose I find that my output is not correct, I have taken the wrong assumption, I have taken the wrong biases, I will go back, I will correct my weight, and next time if I make the correction, okay, next time if I take the action, there is a chance that I will get the good result, right? This is how in our real life happens. Okay, so this is what happens in a neural network at the mathematical level. Okay, I repeat, we have inputs, we have layers, we have neurons, and we have to assign a weight, and this is totally random. We don't know, we are not God, we don't know whether this is a right weight or wrong weight, we assume. Okay, and we perform this mathematical operation inside every cell, every neurons, and it produce weight. Okay, and it keep on going in every layers, finally produce a weight. And if we do comparison, if the result which I was expecting is not same, then I need to update my weight. Okay, this is what happens. Okay, so now here let me again, if you understand this whole concept, okay, so again let me explain what happens. Just let me summarize what happens here. Okay, so let's suppose this is my inputs layer, this is my hidden layer h1, and this is my output layer o1. Okay, so we assign some weight, so we had some weight, uh, we have some weight here for this layer, we have some weight here for this layer. Okay, and these all are connected, this is connected with this is connected with this connected with this, all connected, this is base, this is base, this is all connected. Okay, let's suppose, and we build some equation. Okay, it produces result o1, o2, and o3. Again it went to output layer, it produce action. Okay, it produce a result y predict. Okay, so this part is called the first part, if you're moving in the forward direction. Okay, so here we are moving in the forward direction. In the forward direction, whatever x I have, whatever weight I have, whatever bias I have, we build a equation like xw plus v. Okay, and we perform transformation on that, and we get result. Okay, this portion, this action is called, we give a name, it is called forward propagation. It's a technical name. We call it forward propagation. Okay, and once we get the output, this is the in the forward direction. It happens in the forward direction. Once we get the output, okay, and this output we got based on my bias, weight and bias, because we have assumed that I don't know whether this weight whatever we have taken is a right or wrong. I have just assumed that. Let's suppose I got the weight output and this output is not accurate. What I will do, I will go back in the network, okay, and whatever weight I have assigned, I will update. So this weight, this bias, this weight, this bias will got updation. So it will update all the weight, all the bias. So this portion is called backward propagation. It is called backward propagation. Okay, so in the forward propagation we use linear algebra. Like these all are like multiplication, like creating like x into w plus b. What is this? It's a mathematical matrix calculation. So we apply the linear algebra concept, okay, and we perform transformation on that. So in the forward propagation, it apply the linear algebra, all the matrix calculation, and in the backward propagation, okay, if the output is not matching, we have to do updation. This always, okay. During the backward propagation, we apply the calculus. It is called multivariate calculus. Okay, and this is what this person, Jeffrey Hinton, this person is called also called Godfather of AI. Why it is called Godfather of AI? Because of backward propagation. This person worked around 20 years just to build this algorithm using multivariate calculus. Okay, so only because of backward propagation, because now we have the mechanism, we have a process to update my weights. Let's suppose if it is not possible, if we cannot update the weight, it is not possible to build a network, and you will never get any result or correct result. You will get result, but you will always get wrong result. Let's suppose in your life, okay, let's suppose you have assumed something, you got input, you got something inside, you assume something, this is okay, this is okay, you have some weight, you have some bias, you take action, right, and you're making mistake, but somehow there is no way to come back, do realization and correcting your weights. You will never get result, right? Maybe you will surrender, maybe you will not, you will stop it, okay, maybe you will start something different, right? So there should be mechanism to whatever we have assumed, that whatever weight biases I can correct it, so that next time if I take action, I can reach to my destination. This is what happening in the neural network. Okay, so because of backward propagation, this become very famous, and that's why we are using it. Okay, so if we talk about what happens in neural network, I hope you're able to understand how it works at a very fundamental level. I know that there are a lot of details. Okay, so here what we have to learn, there are a lot of things here. There are a lot of concepts here. Okay, that we have to learn. Okay, so first concept is what call, first of all you have to understand forward propagation, how it works, okay, which I give very high level, okay, how the matrix calculation happens, linear algebra happens, okay. Second, you have to learn about the backward propagation, which is very fundamental, very important, okay, and it happens with the help of there's a concept called gradient, which these are the concept that you have to learn, okay, in your network. What is the gradients? I hope you know what is the gradient descent, right? If you know the machine learning, there's a concept called gradient descent. Okay, so backward propagation use gradient descent concept to optimize or to update the weights. Okay, and then you have to learn, like I told, right? In every neuron, we perform some transformation. Okay, once we build this line, we perform some transformation. So it is called activation. We have some functions. Okay, it is called activation. We perform some function on the uh, we call it activation function. So whatever we get, right, x into w plus b, this input, we perform some action on it, we apply some function, okay, it is called activation function, which we have to learn. Okay, after that, there are a lot of concepts like weight. I told, right, your weight is very important. I mean, what you assume Suppose you let's suppose whatever you have pretended, whatever you have assumed in the beginning is right, then you will reach to the destination, right? So how to assign the weights? There are a lot of researcher had work on that. There are multiple ways to do the initialization. It is called weight initialization. There are a lot of things. There are a lot of concept around that you have to learn. Okay, and then again, so these are the basic, I would say. If you understand what is the forward propagation, backward propagation, some activation functions, some weight innovation concepts, okay, then you have pretty much decent knowledge. You will have some decent knowledge of, you would say, neural network, how it works, okay. Apart from that, if you really want to very good depth, okay, and the most important part in this concept is the descent, gradient descent, this part, okay. How really, this is the amazing part. Only thing, just one thing which make this network very fascinating for me is the backward propagation. How the real update happened, that is amazing, okay. And for that you have to really understand the concept of optimizer, how to do optimization. There are a lot of optimization, okay. You will understand how to the what are the different way to optimize or change the weights in the network. So you have to understand optimize it, okay. And there are a lot of things like like performance wise, okay. Suppose you are doing something and uh, you want to get better performance of a network from neural network. So what are the different ways? There are a lot of way to get the high performance, okay. Like a lot of concepts, I will not talk about that, okay. So if you really want to master this neural network, so these are the basic fundamental concepts that you have to learn, okay. And if you understand these concepts, okay, but I'd explain that, then I think you have a basic, now you are building a basic foundation right now, okay. We have not gone in very depth, but it's good to start have a basic foundation, okay. This is what it does, okay. It's a mathematical level. I think yeah, next video, okay. I don't want to take a lot of, I don't want to take a lot of data in the same video, in the same time, okay. So I hope in this video I was able to build the mathematical, I mean, my whole idea was to build a mathematical intuition. I hope I'm able to do that. But still, if you have any doubt, put in comment box. I will try to solve that. Okay. Maybe in the next video, I will take one more video on that. I will talk about on the graph basis. Okay. Graphically, just try to understand the graphically how it works and what is the geometrical. This is also very important. What are the geometrical intuitions of a neural network? What it does. Okay. This thing I want to cover in the next video, not in the next video. Okay. So yeah, this is all in this video. I hope I was able to explain in a very nutshell in what is the neural network, how it works, the mathematics behind it, and this real life problem. This if you really want to understand networks, this is the analogy you have to you have to just remember. This is what, and in our real life also we follow a lot of this concept, this principle, okay. So this is all in this video. I hope you got some understanding about networks, how it works, okay. And I will come back in the next video. I will talk about more about it in the introduction part. Till then, goodbye, take care. I will come back.